Hello, folks. We're going to be looking at day 3 here, which is going to be function operations. And basically what it boils down to is add, subtract, multiply, and divide functions. But I am going to try and highlight any of the danger areas which would cause people to have issues. Please keep in mind, once again, we do have a Math Excel assignment for you guys to be working on. So let's get started. First off, a domain and range wrap up from the last lesson, just to really briefly kind of talk about what have we got here. Well, I'm going to be looking at my domain, okay? Notice once again, I've got this lovely arrowhead here telling me it's going on and on and on forever. So that means I am going as far to the left as is possible, but I come to a dead stop here. So I'm going to say it's going to run from negative infinity to 3. Next thing I need to do is talk about my range. Again, my range of values, again, I have to stay, I've got my arrowhead here, which tells me that my y-coordinates start at the very bottom, and it goes up to stopping right there. So I'm going to say it's going from negative infinity to positive 4. Let's keep answering questions as we roll along on this. What is f of 0? Real briefly, remember, what does that mean? All we're going to do is we're going to substitute it into my function. And since my function in this case is the graph, so I'm going to say, what is the value when my x-coordinate is 0? Oh, it's right up there at 3. Next up, the x-intercepts. What are x-intercepts again? They're going to be the spots where it hits the x-axis. Okay, well, that doesn't sound incredibly difficult. I can find those pretty quickly and say, well, here's one, here's the other. Please remember to write them as an ordered pair. If you don't, next year's teacher will probably lose their mind and I'll have to mark it wrong. And I'm assuming, not surprisingly, the next thing we're going to do is look at our y-intercept, which is where it hits the x-axis. Just like your x-intercepts are going to be where it hits the x-axis, the y-intercept are going to be where it hits the y-axis. So in this case, we're going to say something real simple like, oh, it's going to hit it at 0, 3. Okay, now let's get into the slightly more challenging things. And these are the ones that, well, people tend to struggle a little bit more with. It asks you to find the values for which f of x is less than or equal to 0. Now, what I'm going to do is I'm going to draw a line. This line here is where f of x, or y, is equal to 0. And since I'm looking for where it is less than or equal to 0, I'm going to say it's the part of the line that is up to here, but also down below. So I can say, what values of x am I looking at? Well, it's definitely going to be including this section in here. Again, my arrowhead is still there, so I'm going to say it's going to be from negative infinity to negative 3. But please note, it does get back to 0 here, so I also have to make sure I include the x-coordinate of 3. And the last type of question is going to be, find the value of x for which f of x is equal to 4. Well, all we need to do there is look at my graph and say, when does my y-coordinate equal that 4? Well, let's see. When does my y-coordinate equal 4? Let me see. Oh, right up there. So I'm going to say that is the value when x equals 1. Okay, and I could ask you the same sort of questions using, say, this graph. I'm looking for when is it, what is my domain? What is my range? I'm looking for x-intercept, y-intercept, all that sort of thing. Well, my domain is going from negative infinity to positive infinity. My range, however, if you notice, the arrowhead is pointing to the right and to the left. It's not pointing up and down, so it doesn't go up forever. So I've got a clearly defined section where it is defined. It's going from y-coordinate of negative 2 to 2, so I can do things like that. Next up, let's see what else I can mess with on this. How about I look for g of 2? Once again, those are going to be easy. Just say, okay, if my x-coordinate is 2, what value does my function take on? I'm going to say a y-coordinate of -2. I could also try and find what g of -4 is. Here is my x-coordinate. What y-coordinate does that get me? That gets me a value of 2. And g of 10. Now, before trying to turn this into something very complicated, I don't see that on there, but what have I got? I've got a horizontal line, which means it's going to stay at that level, which means it's going to take on -2. For what value of x is g of x going to equal 1? Okay, in other words, what x value is going to get me a y-coordinate of 1? So I'm looking here and I'm going to say, well, my y-coordinate of 1 is there. What is the point at which I'm getting that x-coordinate? Oh, just like that. And then finally, values for which x for f of x is greater than or equal to 0. This time, it's not less than, it's greater than. So how do I describe that? Well, once again, I'm looking for my little line that I'm going to draw and saying, this line is where it's going to be equal to 0. So where is it above that line? And I'm just going to say, oh, that's in between -infinity and 0. Again, it's a closed bracket because it also includes that 0 value. All right, let's dig into the new stuff, which is function operations. And I'm going to tell you right now, just copy this stuff down. It's not incredibly exciting. When something is written out saying that you've got any of these things, I can break it up into its pieces. If it is written in this form here, when it comes to doing the execution, I would just break it into its pieces and add them together. Because it's a difference in this case, I have to make sure that I'm distributing the negative into this and then adding. Product rule is pretty straightforward, even though sometimes you may have to use the FOIL technique or double distributive. And then the quotient, the only thing you really need to be careful about, other than maybe reducing, is you have to try and see whether or not g of x can ever be equal to 0. Now, I would encourage you to pause this for just a second so that you can get through this and copy it all down. Okay, let's move on to an actual example where I'm going to show you some work. These are my two functions. Okay, so I would copy them down. And now I'm going to say, well, what do you really want me to do? It says that I've got f of x, f plus g of x. What is that going to get me? Well, all I'm going to do here is, and I'm going to completely cheat, because I think for some of you, this sort of visual might be a little bit easier. So I'm going to say, all right, I know that g of x is this, and I know that f of x is going to be, f of x is what I've got there, and my g of x is going to be that. So what do I need to do to those things? Well, if you notice, the sign between these two things is just going to be addition. So all I'm going to do is I'm going to add these two things together. That's a matter of combining like terms. So I can say, well, greatest power is x squared. So I'm going to say 1x squared plus, next I'm going to call it 2x, and minus 1x, which is going to get me just a positive 1x. And then finally, I'm going to say positive 1 and positive 2 is going to get me a positive 3. And there you go. Not too difficult, and hopefully not a big struggle. So let's take that, and guess what? We're going to end up using these same things all over again. Because the next operation that it asks me to complete is going to be the difference between these two functions. So here's one function right in here, and here's the second function right over there. Now I'm supposed to subtract these two. Now when I'm subtracting, I would very much highly encourage you to take the extra couple seconds and write that down as a set of parentheses, because then you're less likely to run into the issue that many people have. So I still have 2x plus 1. I'm now going to subtract x squared, And then I have to apply this negative to every term in here. So it's going to be minus a negative x, and then it's going to be minus a positive 2. Now, minus a negative is the same thing as plus a positive, and minus a positive 2 is just the same thing as just plain minus 2. And now, once again, I'm going to just combine my like terms together. So I've got a negative x squared from here. I'm going to combine together my 2x and my positive x here. So I'm looking at 3x. And then finally, I'm going to be grabbing my positive 1 and my negative 2, which is going to get me negative 1. So I'm now looking at an answer like that. Okay, and again, you can pause it and copy this down. And moving on, make this stuff go away again because I want to reuse those same functions. Give it a second. All right. The next one I'm asked to do is the product of the two functions. Okay, here are my two functions again. I grab this one here and grab that one there. Now, since I'm going to multiply, what I need to do is take this times that. And for those of you that are, reaching back, and Algebra 1 may be a little bit of a more foggy memory, I would encourage you to be careful in the process. But what I'm going to do is I'm first off going to distribute 2x to every term here. 2x times x squared is going to get me 2x to the third. 2x times negative x is going to get me a negative 2x squared. And 2x times positive 2 is going to get me a positive 4x. So far, so good, except I've only distributed the 2x. Time to change gears and distribute the 1. 1 times x squared is going to get me 1x squared, or just plain x squared. 1 times a negative x is a negative x. And 1 times positive 2 gets me a positive 2. Now that I've distributed, all I need to do is collect my terms together. So here we go. I've got 2x cubed. Don't have anything else that's a like term, so I can't really do much with that. Next up, I'm going to say a negative 2x squared and a positive 1x squared, which is going to get me a negative 1x squared. Okay, next up, I am looking at a positive 4x and a negative 1x, which is going to get me a positive 3x. And then finally, the last term that I've got hanging out by itself is positive 3. And, whoops, it shouldn't be a 3, that should be a 2. Shame on me. Okay, let's fix that right away, because 1 times 2 is going to get me 2 here, so therefore this is not a 3, that is a 2. Okay, and once again, I am back down to my final answer. All right, and let's see what else I've got to play with. Got to give me one more because I've done all the other operations. Oh wait, f divided by g of x. So let's see what we can do here about cleaning this one up. And once again, let's pull this down and pull this down. And they want to take f divided by g of x. Now, when we get a little bit further in the process, this will get a little more involved. But we can't factor and cancel because, well, let me take a look. If I try and factor this, it doesn't end up going well. So I can't factor this expression, and this one, factoring it doesn't help me. So if I can't factor and cancel, the best thing to do is just leave it alone. All right, so done with that part. What else can they possibly throw at you using the operations? Well, I suppose what they could really do is just throw something a little bit more complicated at you. And they say 3 times g of x minus 2 times f of x. What does that equal? All right, so let's go here and there for a second, and I'm now going to actually construct what they're giving me. So 3 times g of x, because that's my g of x, minus 2 times f of x. Okay, still going. Let's see what I can do about cleaning this up. 3 times x is 3x squared. 3 times negative x is negative 3x. And 3 times 2 is 6. And now I'm going to try distributing the negative 2 here. I'm going to have negative 2 times 2x is a negative 4x. And negative 2 times positive 1 is going to get me a negative 2. And now let's just combine together my like terms, which means I'm looking at 3x squared. Got that. Then 3x, and negative 4x is a negative 7x. And then finally 6 minus 2 is going to get me a positive 4. Okay, hopefully that made decent sense. And what I could do is I continue to go through and do more of these questions. Now, the problem is at this point we need to change things up. Let's say I asked you to find f plus g of 2. And I'm going to be honest with you, there are 2 ways to do it. You could actually figure out what f plus g of x is and then substitute in the 2. But I'm going to be honest, it's probably going to be easier for us to just do direct substitution straight away. So what I'm going to do in order for me to get there in this case is I'm going to figure out what is f of 2 and what is g of 2. Okay, so how do I go about doing that? Well, all I need to do, again, remember from what our discussion was previously, I'm just going to substitute 2 in there and substitute 2 in there. So I'm looking at 2 squared is 4. 4 times 3 is going to be, now let me write it out, because I don't want anybody to be having issues on this. Okay, so I'm looking at 2 squared is 4. 4 times 3 is 12, and I'm looking at 12 minus 1 is 11, plus 2 squared is 4. 2 times 2 is 4, so I'm looking at 4 plus 4 minus 1, so I'm looking at 7. So 11 plus 7 is 18. And you're done on that. Next, what else could I do? Well, I could ask you to find f minus g of 0. And once again, I'm looking at my function, and I'm actually going to recopy it so I can see it better. F of x equals 3x squared minus 1. G of x equals x squared plus 2x minus 1. So all I need to do now is substitute my values in, and I need to find, let's go for f of 0 minus f, or g of 0. Well, f of 0 is going to be easy to do because all I need to do is substitute 0 in there, so I'm going to be looking at negative 1 from that. And then once again, I'm going to substitute 0 in there and 0 in there, and I'm going to be looking at a negative 1 for that. So I'm looking at negative 1 minus a negative 1, or minus a negative, same thing as plus a positive, which is going to get me 0. Okay. Can I do other things with these? Sure. It will work. Sometimes it's going to take a little bit more time, but we can do the same sort of thing with other problems. So for instance, I'm just going to move that pair of functions down, and I'm going to hit my last one here. And I can say, well, can I do this? Sure. I'm just going to say, let's take f of 1 times g of 1. And again, I could distribute, but there's not great value in that, so I'm going to just say, let's see, 1 squared is 1, 1 times 3 is 3, 3 minus 1 is 2. And then g of 1, I just sub in there, so I'm looking at 2 times 1 plus 2 minus 1, or 2 times 2, which is going to get me 4. Okay, so far so good. All right, let's change things up to do a graphical interpretation. Now, this is apparently something that SAT is looking to be throwing at standardized tests. Don't worry, it's nothing incredibly difficult. All we need to do is find the same stuff that we were finding last time. You've got a graphical interpretation of what f of x is, and a graphical interpretation of what g of x is. So in order to find this, I need to find what is f of 1 and find what is g of 1. Okay, I'm going to go to my graph, and notice I've got my f of graph right here in yellow, and I'm looking for, given an x coordinate of 1, which is what this is saying, what is my y coordinate? So I go up there and I say, well, it sure looks like that y coordinate is going to be 3. Next, I'm now going to look at my g of x function, which I've now highlighted in green, and I'm going to say, hey, what is my y coordinate when I'm plugging an x coordinate of 1 in? So I'm going to go down here and I'm going to say it sure looks like I've got a y coordinate of negative 5. So I'm looking at 3 plus a negative 5, which is going to get me, how about negative 2 there? Okay, so far so good. Hopefully fairly easy. Let's take a look at the same idea and let's see what we can do about dealing with g divided by f. So once again, I'm going to interpret this as being g of 0 over f of 0. And once again, I need to figure out what the values are here. So let's take a look at that. So I'm going to say, once again, we've got my f of function. This time we'll do that one in green. And my g of function is down here. So starting with the g of function, I need to say, well, at g of 0, what is my y coordinate? Sure looks like it's negative 4 to me. So I just go negative 4 there. And then I'm looking for my f of function. It's up there. Looks like a y coordinate of 2. So I'm looking at negative 4 divided by 2 is a negative 2. Coolness. What else do we have? Well, let's take another crack and see what we've got to mess with on the next one. It says f minus g of negative 1. So again, I'm going to say, what is f of negative 1? And now I'm going to subtract g of negative 1. Let me go back here, and we now know where the f of function. So I'm going to say, well, what is f of negative 1? Well, here's my negative 1. What is the corresponding y coordinate? I'm going to say that's 1 minus what is g of negative 1. So I'm going to go down below, and I'm going to say that looks like it's at negative 3. So minus a negative 3. 1 minus a negative 3 is going to get me 4, and I'm done with that part. Okay, and clean it up one more time. We'll take a crack at one more here, and we're going to say f times g of negative 4. All right, so that will get me f of negative 4 times g of negative 4. And all I need to do is figure out what my f of negative 4 is. So I go over here, here's my negative 4. I go up top, I say, ooh, that's giving me a value of 2. And g of negative 4 is going to get me 0. So I'm now looking at a value of 0 there. Okay? And again, these graphical problems can be a little bit intimidating because they're a little bit different than just standard plug and chug math. What else could SAT throw at you to make life difficult? Well, they could give things to you in a chart form. And don't worry, this is just more of the same. They're asking you to do the same sort of thing, except that now it's in a chart form. So here we go. I'm now asked to find what is f of 0 plus g of 0. So f of 0 is here, g of 0 is there, and I'm going to say, well, let's go over and look at my lovely little chart. And I'm going to say, down here is my values for 0. So I'm going to look for f of 0 is 4, and g of 0 is 5, and I'm looking at a value of 9. That wasn't so bad. Let's see what else we can do if we're looking at something maybe a little bit different there. Okay, how about f divided by g of negative 1? Okay, so what is g of negative 1? And what is f of negative 1? Well, let's see. Again, going back and finding my negative 1 column, I've got that g of negative 1 is going to be 0, and f of negative 1 is 2. 0 divided by 2 is 0. Okay, and we could keep going on this for quite some time, but let's just do one more. I'm going to say, what is f minus g of negative 3? Here we go. I need to find f of negative 3, and I need to find g of negative 3. All right, and let's grab my values at negative 3. So at negative 3, I'm now looking at these values. So let's fill stuff in. I'm looking for f of negative 3 is 3, minus g of negative 3 is a negative 1. So 3 minus a negative, same thing as plus a positive, is a value of 4. Well, I'm truly hoping that this will get you through the rest of this problem and the rest of the Math Excel, and I hope you have a great weekend, and I'll look forward to seeing you guys next week. Take care, have fun,